Okay, so welcome back for this calculation of great circle sailing. So after we created our spherical triangle, so this is the representation of the path of the great circle track. So this is our north pole. So we already identified the parts of our spherical triangle. We have the small a, small b, and we have the big C, or this is represented by our DLO. So to solve the remaining parts, such as this A, C, and B, we will use the formula of cosine law for spherical triangle. So if you are not yet familiar on how this formula was created, you can watch my tutorial about cosine law. And please include also the Napier's rule because we will use it for determining the latitude of vertex. So now, first we need to identify the C. So this is the formula. Cos A, cos B, plus sin A, sin B, cos big C. So I already computed these letters so that we can immediately move. And this is my computation. So cos A, so this cos C, the answer is 97.05 degree. (97.05 degree). This is the arc of this point until this point in degree. If you multiply it by 60, your answer is 5,823 minute or nautical mile. And this will be your great circle distance. So simply measure this arc. So in this calculation, by spherical triangle using cosine law, you will not make a mistake because sometimes if you are going to search the formula on the internet, it will give you cos lat, it will include or it will immediately inform the latitude, the dilo, lat. So you have to be careful because if you did not understand how this great circle was formed, maybe you have a lot 5 here, 5 north, and you have a lot 5 south. So if you have different hemisphere, it will create a different shape of your great circle track and your spherical triangle. So for me, the best way to calculate the great circle sailing is by the use of Napier's rule and cosine law because this formula will not help you anymore if you are going to identify every waypoint of the great circle. So this is useless anymore if you are going to identify these waypoints. You have to divide it and solve it by spherical triangle. Okay, so now we already determined how to solve for great circle distance. Now, how about the initial course? Initial course, we represent it by A. So my answer is 44.6 degree. 44.6 degree. Means from the arc of north, because this is North Pole, to this initial arc or initial course, as is, this is 44.6 degree. So now let's identify the final course. It's look like the vessel is traveling here and like somewhere going here. So let's identify the final course by calculating the value of B. So my calculation by cosine law formula, my answer is 82.8 degree. 82.8 degree. So look at the arc. 82.8. So this arc is going from north, going to North Pole. To North Pole. You have an arc here of 82.8 degree. So the final course is that the vessel is pointing like this. Going down. So this means that the final course is from the direction of true north to here. So it's very easy. Yes, the true north is 360 minus 82.8 and minus 180 degree. And your final course is so let's calculate 360 360 minus 82.5 minus 180 and the answer is 097.2. So on this part, the ending of the track, the course or the vessel is facing on 097. So the initial is 044.6 initial, and the vessel will travel until it reaches the maximum latitude. Then it will go down, and the final course is 097.2. So this is the method of calculating the Great Circle sailing via cosine law to determine initial course, final course, and the Great Circle distance. So initial course, Great Circle distance, and the final course. So now, the next procedure is we have to identify the latitude of vertex. So vertex is the point where you have a 90-degree on the meridian and the latitude, or the latitude is the highest latitude part of the great circle tract. The highest latitude part of the great circle tract.